Did you know that plywood is far more than just pressed wood? It's considered a symbol of clever engineering, where resource efficiency and remarkable strength come together in a single material. The production process begins with round logs that are peeled into thin veneer sheets. These veneers are then dried, coated with adhesive, stacked with alternating grain directions, and hot pressed under high pressure to form multi-layered boards. Thanks to this structure, plywood has become an engineered wood material that is both strong and dimensionally stable, widely used in construction and furniture making. But what exactly has made this seemingly simple material the first choice across the globe? Stay tuned as we uncover the journey that transforms ordinary logs into sturdy plywood sheets, a material that has shaped the face of modern architecture and interior design. The rise of the engineered wood industry, especially plywood, rests on a foundation that often goes unnoticed: planted forests, managed like a carefully designed green machine. Unlike natural forests that can take centuries to regenerate, plantations of acacia, eucalyptus, or pine reach harvestable size in just 7 to 20 years. Each hectare usually holds 2,000 to 3,000 trees, staggered in different age groups to ensure a continuous supply, a model that frees the industry from relying on the logging of old-growth forests. Globally, industrial plantations now exceed 290 million hectares, providing more than half of all raw material used for plywood. The cycle is tightly controlled from seed, bred to produce straight trunks with uniform grain, to the nursery stage, then on to maturity in the plantation. Trees are planted in plots with carefully calculated spacing to maximize land use while ensuring light and nutrients are evenly distributed. Throughout their life cycle, they are pruned, fertilized, and protected from pests to optimize every cubic meter of wood. Once ready, harvesting is mechanized. Trees are felled, debranched, and cut into logs. Straight trunks are destined for veneer, while tops and smaller branches become biomass fuel to power the very mills that process the wood. The ecological impact of this model is profound. Without plantation forests, global demand for plywood alone would put immense pressure on millions of hectares of natural forests, ecosystems that need centuries to recover. Instead, the closed-loop cycle of plantations enables rapid renewal, reduces carbon emissions, and safeguards wildlife habitats. That's why each sheet of plywood represents more than an industrial product. It embodies a philosophy of balance, turning planting, harvesting, and regeneration into a sustainable cycle where economy and environment work side by side. When logs leave the plantation, they still retain natural moisture within their fibers. Yet once stacked at the mill, if not carefully managed, they can quickly dry out, crack, and lose their natural resilience. That's why the log yard serves not only as storage, but also as a kind of rest station for raw material. Here, the timber is regularly misted or sprayed with water to maintain stable humidity, preventing deformation during storage. These artificial sprays don't just moisten the surface. They balance the moisture between core and bark, reducing splitting and curbing the spread of insects and fungi. From a distance, the log yard resembles a vast reserve, where thousands of trunks lie in neat layers under meticulous care. This preservation ensures each log retains its original quality, safeguarding the stability and strength required to advance into the industrial cycle. Before processing begins, the logs are immersed in hot water basins or placed in steam chambers at temperatures ranging from 80 to 100 degrees Celsius. The heat softens the wood's structure, allowing cellulose fibers to expand and relieving internal stresses, which prevents the logs from cracking. Depending on the species and diameter, soaking can last anywhere from several hours to an entire day. During this period, heat and steam penetrate all the way to the core, creating uniform consistency from the outside in. Once removed from the basin, the logs have reached the flexibility and stability required, ready for precise machining. Once the logs have been softened by heat Each trunk is cut into sections measuring 1 to 2.6 meters in length, depending on the panel size to be produced. Before cutting, the logs are aligned using a laser measuring system or mechanical gauge to determine the optimal length, maximizing usable volume while removing major defects. The ends are then cut flat, smooth, and square to ensure a secure grip when mounted onto the spindle of the peeling lathe. At this stage, the entire log begins to rotate at speeds reaching hundreds of revolutions per minute, turning the trunk into a giant wooden roll, ready to be unwound. A steel knife more than 3 meters long, sharpened at an angle of about 20 to 23 degrees, presses firmly against the surface. Opposite it, the nose bar applies steady pressure, compressing the fibers and preventing cracks during peeling. With each revolution, a thin veneer layer, only 1 to 3 millimeters thick, is sliced away, unrolling in a continuous wooden ribbon. Veneer thickness is precisely determined by the micro-adjusted distance between knife and spindle, combined with rotation speed. A deviation as small as 0.1 millimeter can render an entire sheet unusable. Modern control systems integrate real-time thickness sensors, sending continuous data to processors that instantly fine-tune the blade. This ensures every veneer sheet remains consistent. Not so thin that it tears, not so thick that it resists pressing. When the log is reduced to a small core that can no longer be peeled, the veneer is cut crosswise into standard panels and stacked neatly. From a single solid trunk emerge flat, smooth, and uniform sheets, the technical foundation behind plywood's extraordinary strength. Freshly peeled veneer still contains a high level of moisture, often exceeding 30%, leaving the sheets soft and prone to deformation. To achieve stability, they are fed into specialized drying systems, long hot air chambers stretching for tens of meters, where temperatures range from 150 to 180 degrees Celsius. The thin veneers are placed on conveyors and pass through successive heating zones, while powerful fans blow hot air evenly from top to bottom. Within just 5 to 7 minutes, the moisture content drops to only 6 to 8%, the ideal range for preserving both flexibility and mechanical strength. This drying process requires a delicate balance. Excessive heat can cause warping or cracks, while insufficient heat fails to reach the necessary dryness. For this reason, sensors continuously monitor temperature and humidity, transmitting data to the control room for instant adjustments. At the end of the chamber, the veneers are cooled naturally in an enclosed environment to prevent thermal shock. The result is a stack of thin, flat, and stable sheets, perfectly conditioned for the next stage of production. Once the veneer reaches stable moisture levels, it enters the gluing stage, a critical step that bonds the layers together. The most common adhesives are urea formaldehyde for furniture-grade products or phenol formaldehyde for outdoor applications, where resistance to moisture and weather is essential. On the production line, each veneer sheet passes through a rolling or spraying system that applies an even coat of resin only a few dozen microns thick, just enough to penetrate the fibers without leaving excess. Viscosity, temperature, and resin volume are all tightly controlled. Even the slightest deviation can reduce bonding strength. Optical sensors continuously monitor coverage, making instant corrections if any area receives too little or too much adhesive. As a result, every veneer sheet emerges with uniform coating, perfectly prepared to be layered into a strong, multiply structure, the very foundation of plywood's engineered performance. Once the veneer layers have been coated with adhesive and stacked with their grain directions set perpendicular, they are transferred into a cold press. This equipment uses a hydraulic system to apply uniform pressure across the entire panel surface, typically ranging from 0.8 to 1.2 MPa. The pressing time lasts 15-30 minutes, long enough for the glue to spread and hold the veneer layers in place, though not yet sufficient for the chemical reaction to be fully completed. The purpose of this stage is to stabilize the shape of the panel, eliminate air gaps, and ensure tight contact between the veneer layers. If the cold pressing step is skipped, the adhesive may distribute unevenly, leading to delamination or warping later on. After the cycle ends, the multi-layered panel has taken on its preliminary form, strong enough to be safely moved to the hot press, where higher pressure and temperature will finalize the bonding process. After cold pressing, the glued veneers are transferred into the hot press, the stage that ultimately defines the quality of plywood. The press uses thick steel heating plates that distribute heat evenly across the board surface. Temperatures are typically maintained between 120 and 150 degrees Celsius, while hydraulic pressure can reach 1.0 to 1.5 megapascals. And under the combined effect of heat and pressure, the resin undergoes a chemical reaction, penetrating deep into the fibers and bonding the veneers into a single unified block. Hot pressing time varies with panel thickness, usually lasting 4 to 7 minutes per cycle. Throughout the process, sensors constantly monitor temperature and pressure, adjusting automatically to avoid overpressing, which could cause cracks, or underpressing, which would leave bonds incomplete. When the cycle ends, the plywood sheet emerges flat and smooth, with uniform thickness and high mechanical strength. It is at this stage that plywood truly takes shape as a finished engineered material, combining the strength of many layers of wood, yet performing as one solid whole. After leaving the hot press, plywood sheets are moved to the cutting area, where they are trimmed to standard dimensions. High-speed alloy steel saw blades make precise cuts with clean edges, while also removing any excess margins or defects formed during pressing. Each panel is carefully aligned to guarantee perfect squareness and uniformity across all sides. Immediately afterward, the surfaces are treated by a multi-roll sanding system. Rotating drums coated with fine abrasives work continuously, gradually removing rough spots and producing a smooth, bright finish. An integrated dust extraction system captures wood particles throughout the process, keeping the surface clean at every stage. Thanks to this finishing step, each plywood sheet achieves high geometric accuracy, along with a uniform, refined surface ready for further use. Before leaving the production line, every plywood sheet undergoes a quick inspection for thickness, flatness, and layer adhesion. Basic tests such as bending or bond strength checks ensure that no sheet contains technical flaws and that each one meets usage standards. Right after testing, the panels move to the packaging area. They are neatly stacked into bundles, ranging from several dozen to as many as 100 sheets, and secured with steel straps or heavy-duty plastic bands. Each bundle is wrapped with a protective layer of polyethylene film or craft paper to guard against moisture during transport. Labels are attached to specified dimensions, production batch, and quality certification. Finally, the bundles are lifted by forklifts and transferred to the storage area, a dry, well-ventilated space with stable temperature. Here they are arranged in orderly rows, ready for dispatch and distribution to the market. In the plywood production line, nothing goes to waste. The remaining log cores after peeling, along with edge trimmings, defective veneers, and small branches, are all collected and sent to the particle board line, where they begin an entirely new industrial journey. First, the wood residues are chipped into particles of different sizes. Larger chips are reserved for the core layers, while finer ones are used for the surfaces. The particle mass then passes through vibrating screens that remove impurities, metals, or oversized fragments. Next comes drying. Hot air at 150 to 180 degrees Celsius blows continuously, reducing the moisture content to just 2 to 3%, the optimal level for bonding. The dry particles are blended with industrial resin, most commonly urea formaldehyde, along with a small amount of paraffin or moisture-resistant additives. This mixture is spread in multiple layers on a conveyor. Fine particles on the outer surfaces, coarser ones in the middle, forming the familiar three-layer structure. The entire particle mat is then loaded into a hot press. At around 180 to 200 degrees Celsius and pressures of several megapascals, the resin melts and penetrates deep, locking each chip into a solid board. Once it leaves the press, the panel is cooled, trimmed to standard dimensions, and sanded smooth. The result is a flat, stable engineered material, cheaper than plywood yet suitable for many applications in furniture and construction. In this way, the factory operates on an almost closed-loop system. Plywood makes use of high-quality log sections, while residues are reborn as particle board, minimizing waste and extracting maximum value from every tree. From a tiny seed in the nursery to vast plantation forests, through harvesting, log cutting, veneer peeling, drying, gluing, and multi-layer pressing, every step contributes to the making of a complete sheet of plywood. Each thin veneer is laid with intent, every technical detail strictly controlled, forming an engineered material that is both strong and stable, capable of serving in everything from household furniture to industrial-scale architecture. Even wood residues are not wasted, but reborn as particle board, closing the life cycle of each tree within a sustainable production model. This journey shows that plywood is far more than just laminated wood. It stands as a symbol of technical ingenuity and harmony with nature. If you were impressed by this process, share your thoughts in the comments below. And don't forget to hit like and subscribe to our channel